Okay, so I know today was complicated. Last couple weeks has been complicated, but I want to redo this for you. So this was the equation, right? But we're going to simplify this. We said in class today that the probability of a true positive, what that is, another way to write this, probability of true positive, is our dependent variable, or y. We also said that the COVID rate was our independent variable, or x. Now, for our purposes today, we have that the PCR sensitivity and specificity is 0.981 and 0.996. Now, for your homework, you're going to have different sensitivity and specificity ratings because we're doing it for the rapid test for homework. But this is what we did in class, so I'm going to redo that. The only difference will be these numbers. Okay, so first we look at the sensitivity rating. Let's do that. Let's do sensitivity and specificity both in green. So the sensitivity rate is 0.981, 0.981. Our COVID rate, remember, is X. Then we divide that by 1 minus the specificity. So 1 minus our specificity is 0.996. Let's put that in parentheses. Times 1 minus the COVID rate, but our COVID rate again is X. Let's do this in black here. Okay. Well, we still have to add to that this sensitivity rating, 0.981 again, and multiply it again by the COVID rate, which is X. Let's do that. So this is all equal to our probability of a true positive, or Y. So this is our equation. Once we've substituted in Y for probability of a true positive, X for the COVID rate, and the sensitivity and specificity for this particular PCR test. So now we take this equation, fancy equation as it is. So we take that equation and we plug it in here. 0.981 rather, X divided by 0.004X, no, 1 minus X, plus 0.981X. Okay, now let's just take a look at this graph. So notice what we talked about before. This is the area of the graph that we're interested in. The domain, or the X values between 0 and 1, and the Y values between 0 and 1. Because remember, the probability of COVID, or the COVID rate, is down here. So there's no such thing as a negative COVID rate. And there's no such thing as a COVID rate above 1 or above 100%, right? That doesn't make sense. And there's no such thing as a probability of a true positive below 0 and a probability of a true positive above 1. So our numbers are between 0 and 1 and 0 and 1. However, when we're graphing this, notice how all the sexiness of the graph, all the fun, all the difference is up in here, right? And in our world, we're never really going to get above 0.2 or 20% COVID rate. Okay, so I'm really interested in between 0 and 0.2 of the COVID rate. So again, down here on our x-axis is COVID rate. Okay, and I'm going to do 0.01, so that's 1% right here. 0.02, 0.03, I'm just going to finish this up. So notice I finished this up and all I got to was 0.11. Now on the back of your homework paper, you might not get to 1, let alone 0.2. So go by these small increments because this means 1% COVID rate. This means 2%. And this goes all the way up to 11% COVID rate, which is honestly as COVID-y as we're ever going to get. In March of last year, we were maybe at 11%, but nobody knows because there was no test. But it was really high then, but we don't know how high. So over here, this is our probability of true positive. So the probability that if you test positive, it is a true positive. Remember, this is all in the world where you tested positive, okay? Now, we're going to do that differently. We're just going to do that 0.1 every 2, 3, and I'll keep going. Okay, and you see how I did it all the way up to 1 or 100% by tenths of a point, okay? So now what I'm going to do is I'm just going to plot a few points from our graph that we've made on here. And how do I do that? You can click on this line, right? And you can kind of drag it with your finger. So I'm going to start at 0.005, which means 0.5%, which means at 0.5%, the probability that you received a true COVID is 55%. So at 0.5%, which is right here, 0.005, probability of true COVID is 55. So I'm going to put a point here. Now I'm going to look back. I'm going to keep dragging and I'm going to go to 0.1, 0.01 rather. Oh, 0.71. So that means a 71% chance. So when we're at 0.1, we already, look how fast it's going up. We go from 55 to 71% chance. Well, I'm kind of curious, what is it at 1.5% chance? Let's look at that. So to find 1.5, that's a 1%. Here's 1.5, 0.015, 78% or 79% already. So at 1.5, we're already almost to 0.8, right? Let's look at 0.02. Again, we're just dragging up along here. 0.02, 83% chance. 0.02, 83% chance. So you see, going by these, so let's look at 2.5% or 0.025. I just go up 0.02, 86% chance. So 86, so a little above here. And let's look at 3, or when 3% of the population has COVID, which we've been at before. That's not too crazy, but it's not great, right? That's when they close. let's say 0.88, so 88%. So almost 90. So as you see, it starts to look very much like this. So it starts here. Oops, I can't even draw. Let's just connect these dots. And then it'll go like that. Same thing this way. So look how it precipitously falls, okay? So this is our graph. That's how you graph it. Slow and steady, one at a time. Now again, the only thing you need to do differently for your homework / mini exhibition is you're going to use, I just need to go back a slide, different rates here. Because now we're going to have a rapid COVID test, which has different sensitivity and specificity ratings. And that's how you do it. Again, tomorrow I will have office hours from 12 to 12:30 because of our special advisory. Have a great day.